concept of left hand derivative and right hand derivative. What we are doing here, we will see under what condition a non-derivable function becomes continuous. Non-derivable, that means may be continuous, may not be continuous. Okay. So we will see under what circumstances, under what condition your non-derivable function becomes continuous. Clear? Let left hand derivative is equals to p. Okay. And right hand derivative equals to q. There is a function we calculated left hand derivative and right hand derivative. One comes out to be p, other q. Now, if p equal to q, if p equals to q, then function is what? Then function is derivable and let's say at x equals to a. At x equals to a, and thus it will be, or it is continuous at x equal to a. No, no. The first point we already know. It is very straightforward. If left hand derivative equals to right hand derivative, that means it is differentiable. If it is differentiable, that means it is continuous. Okay? If p and q are finite, if p and q are finite, but p is not equals to q. Okay, that means left hand derivative is not equals to right hand derivative. No. P and Q are finite. That means you are calculating left hand derivative and right hand derivative. That both are coming out to be finite values, but they are not equal. So first of all, then function is non-derivable. Yes or no? At least this much we can deduce. Yes or no? Function is non-differentiable. Then what happens to continuity? Remember, if not differentiable, then both conditions are possible. It may be continuous, it may not be continuous. So understand this. If I write left hand derivative, limit h tends to 0, f of 0 minus h minus f of 0 divided by minus h, and right hand derivative limit h tends to 0, f of 0 plus h minus f of 0, sorry, let's say f of a. We are talking about a point. Okay. Now it is given that this is equals to p and this is equals to q. Now it is given that the left hand derivative is equals to p, which is finite. The right hand derivative is equals to q, which is also a finite value. Yes or no? Now, if you look at this denominator, as h tends to 0, your denominator is tending to 0. Yes or no? All of you, focus here. If h is tending to 0, then your denominator is tending to 0 or not? Now, if this limit is finite, then there is only one case where it is possible. Indeterminate form, if we have something in the denominator tending to 0, then the limit will only exist when numerator is also tending to 0. Yes or no? So we can say in the left hand derivative, same here in the right hand derivative. Your denominator is tending to 0. Limit will exist only when your numerator is also tending to 0. Yes or no? How can we say that? Because it is given P and Q are finite, that means this P exists, yes or no? This Q exists. They are not equal, but they separately exist or not. That means if their denominator is tending to 0, numerator must individually tend to 0, yes or no? In LHD and RHD, denominator denominators are tending to 0 for limit to exist, limit to exist, limit h tends to 0, f of a minus h minus f of a must tends to 0 or not. Similarly, limit h tends to 0, f of a plus h minus f of a must also tends to 0. Yes or no? Or I can directly say it is equal to 0. This limit must come out to be 0 or not. Do we agree here? That means can we directly say from there limit h tends to 0 f of a minus h equal to f of a, and limit h tends to 0 f of a plus h equal to f of a. That means what is this? What is this? Left hand limit, yes or no? And this is the left hand limit and right hand limit, both are equal and equal to the value of the function. So in this case, what happens? Function is continuous, yes or no? You understand this? If P and Q both are finite, they are not equal but finite, then it is not derivable. Yes, we understand, but function is continuous. Did you understand this? And did you understand why? Did you understand why? Okay. Now, this is a scenario when we are getting actually a peak, pointed peak. Okay. Whenever we get an edge peak, something like this. Okay. So this function will be continuous or not, but it is not differentiable. If you try to find left hand derivative, it will come out to be what? Finite value. Right hand derivative also finite value. But both are not equal. If you remember mod x, yes or no? Let's say it is x equal to 0. If I calculate right hand derivative from the right hand side, then the slope of this line will also be the slope of the right hand derivative. Yes or no? So it is plus 1. Left hand derivative, it will be minus 1. Yes or no? Both are finite, not equal, but function is continuous. Because it is not derivable because we have a point here. Yeah. If P and Q are finite, but P is not equal to Q, then function is not derivable, but then function will be continuous at x equal to a. So without actually checking whether function is continuous or not, we are directly deducing using left hand derivative and right hand derivative. Yeah. Okay. Online, is it clear? Shashank understood. Kevin, hello, Sarita. Hello is also okay. Okay. Sarita sleeping. Sarita saying yes, sir. Kevin, okay, good. All of you are from Karnataka or nearby place also? What about Hanok is from Karnataka, I know. Sarita, Kevin, Shashank, no, Kevin is from nearby place. I have seen him so many times outside. Shashank and Manasa, I don't know where they are from out nearby. Shashank is from nearby. Okay. What about you, Manasa? Hostel. She's attending the class in the hostel, or she has. Okay. Kevin. He doesn't think that he needs to reply because sir already. But nearby people, why are you not coming? Oh, because of the bunch. So all the students we have today, all are hostel students only. See? Yeah. Brave. Oh, Shashank has fever. Get yourself tested. You came out. You came here but went back. Is that so? Okay. Done. You guys must be so happy about this one also. Yes or no? Yes or no? Only word of mouth. Okay, this is just coming out from your mouth, but actually you are. Everybody is enjoying and we are studying. See, now she's talking. Yes or no? You never doubt class in. You never ask doubt in the class. Yes or no? But this time you are telling. Okay. So still we have one more condition. Where of the song? All of you done? अरे बस हो गया. Guys, be quiet. Third, if P and Q, if at least one of P and Q is or are infinite. Okay, infinite. Then function is not derivable first of all. As soon as P is not equals to Q or P and Q are not finite, it is not derivable. You understand that? Yes or no? But let's continue. Come to continuity. But nothing certain can be said about continuity at x equal to a. Okay, nothing certain can be said about the continuity of the function at x equals to a. It may come out to be continuous, it may not be continuous. We'll have to check. So this concept of LHD and RHD, the second point is important. When left hand derivative and right hand derivative both are finite, then we can directly say it will be a continuous one. Yes or no? If P and Q, if at least one of them, maybe both P and Q are infinite, maybe at least one of them is infinite, then you can directly say, you can say, you can never know whether it is continuous or not. You'll have to check. If any one of them is tending to infinity, no idea. Okay, clear? Let's say if I take an example of f of x equal to x to the power 1 by 3, 0 if x is not equal to 0 and x equal to 0. Quickly check left hand derivative, right hand derivative. Vanessa also suffering from fever and cough. This right hand side, should I rub this off? Just calculate left hand derivative and right hand derivative. Have you started already? Have you already started? Can I make some changes? Calculate the question there. Okay, start. LHL, RHL, both are LHD and RHD. No, no. Left hand derivative and RH, right hand derivative, both are infinity. So what can we say about the continuity? Did you say anything? No. What about here? Done? You calculate the limit, no? What happens here? What happens if you have h cube in the numerator and h in the denominator? Then you will cut the power of h or not. Here also you have the same thing. Cut the power. Okay. Done? That's okay. H is not tending to infinity. H is tending to 0. What are you waiting for? Quickly. That's a derivative, that's a derivative. And what about this? Then apply the limit now. What is it? Make a mistake. Okay. Done? See, if you see, actually, this is only one function. I wrote x not equal to 0, this is equal to this. Yes or no? At x equal to 0, it is 0. Now, if you put x equal to 0 here, again it is 0 or not. So, I don't really need to put this extra condition. Yes or no? Here also, at x equal to 0, I am getting 0 or not. So, I don't really need to put this part. Mistakenly, I put, but it's okay. If you calculate left hand derivative here, let's say left hand derivative, then limit h tends to 0, f of 0 minus h. I will use this definition, minus h to the power 1 by 3 minus 0 divided by minus h. Now this minus sign will come out or not? So cancelled out. Now h to the power 1 by 3 and h to the power 1. So in the denominator, I will be left with 1 by h to the power 2 by 3 or not? 1 minus 1 by 3. Yes or no? 2 by 3. As h tends to 0, denominator is tending to 0, power is 2 by 3, but it is still tending to 0 or not? Let's say in the denominator we had square root of h. Let's say in the denominator we had square root of h. As h tends to 0, square root of h will also tend to 0. Yes or no? Same here, we have h to the power 2 by 3. Power should be positive. That is the idea. Yes or no? If power is negative, then this will go to numerator. Now power is positive. As h tends to 0, this denominator is tending to 0. Whole value will tends to infinity. Right hand derivative. Right hand derivative is again tending to infinity. Yes or no? So if we see P and Q, both are what? Both are infinite here. So we can never say anything about continuity of this function. Yes or no? But if you find continuity, then you will see this is a graph of y equals to x to the power 1 by 3. This is a very standard graph. Okay. Yes or no? Now, if you turn to, let's say x equal to 0 from the right hand side, then the tangent is basically your y axis or not? Array, in any other world, what happens? If you turn to x equal to 0 from the right hand side, then the tangent will be this y axis or not? And slope of the y axis is what? Infinite. Array, y axis is making an angle of 90 degree or not? Tan 90 is what? Infinity. Yes or no? So from the right hand side, it is infinity. Again from the left hand side, y axis is what? Tangent. So again your what? Infinity. So left hand derivative and right hand derivative both are infinity. That means both are not finite. But the function is continuous. If you calculate left hand limit, right hand limit, it will come out to be what? Yes or no? No, not infinity. I'm talking about continuity. Yes or no? If I calculate left hand limit, let's say left hand limit h tends to 0, f of 0 minus h. Yes or no? That means minus h to the power 1 by 3. This minus sign will come out outside. Now h to the power 1 by 3. H tends to 0 is 0. Yes or no? Same for right hand limit also. And exact value is also 0. Yes or no? So it is a continuous function. Quickly copy, then we'll talk about this. Can I rub this part? Point 3. I think all of you have already copied this. So for this question, let's focus for 1 minute, then you can start writing. Left hand derivative, limit h tends to 0, f of 0 minus h, 0 minus h, that means this definition I will use. That means minus h minus 1. This is your f of 0 minus h. Minus f of 0 is basically this definition, yes or no? At 0 it is 0. 0 divided by minus h. So this will be nothing but limit h tends to 0, this minus sign, and I will take minus from numerator common. I will get h plus 1 divided by h. Limit h tends to 0, 1 plus 1 by h. Yes or no? if I take limit, then 1 by h is tending to infinity or not? So this is tending to infinity. It is your left hand derivative. Right hand derivative if I take, then limit h tends to 0, it will come out to be 1 or not? F of 0 plus h, that first definition, h minus 0 divided by h, 1. Now, again here, one limit is tending to infinity, yes or no? So let's see its curve. As x greater than or equal to 0, so it will be x only, so this is the line. As x is lesser than 0, it is x minus 1, again it is a straight line, but starting from where? Minus 1. X equal to 0, y is equal to minus 1, yes or no? X equal to 0, y is equal to minus 1, yes or no? Yes or no? So this line is something like this. So your limit in this case does not exist. Yes or no? We have taken two examples in which in one of the one, in the first example, both left hand derivative and left hand right hand derivative are not finite. But function is coming out to be a continuous function. Yes or no? In the second one, again one of them is finite and the function is not continuous. Do you understand this? So we can never say anything about the continuity if any of the left hand derivative or right hand derivative is tending to infinity. Is that clear? Any DPP left? Or have we discussed all the DPPs? Discussed all? In this case, f of 0 because 0 is here, so 0 is 0. Let's say f of x equal to x to the power 1 by 3 and x when x is greater than or equal to 0 and when x is lesser than 0. Okay? Check whether function is continuous or not. Okay, apply this one. F of x equal to cos x plus mod cos x at x equal to pi by 2. Have I given this question before? Cos x plus mod cos x. Have I given? Okay. Tell me, have I given this question? It is basically ln square x, not ln x square. Okay. Ln square x means ln x whole square. It is just like sine square x. X box x, I think I have given to you. It is about mod x. Given?